do it now, and that is finding the equation of a hyperbola. All right, so let's look, right? What are we given on the graph? We use this graph to find the equation. Now we've been given an asymptote here, which is y is equal to -1, and we've been given a point, one of the points, which is 2, 0. All right, now where can I substitute my asymptote on my general equation that I have here on the right, top right? Where can I substitute it? At Q. Thank you very much. So let's start with that. F of x is equal to a over x, and my asymptote is -1. So now we have successfully found one of the components of this formula or equation. Okay, now we've been given a point 2, 0. And just to remind us, points have a x component and a y component. So we can actually substitute my 2 wherever I see x, and we can substitute my 0 where I see a y or fx. I'm hoping you guys know that fx is the same as y. All right, so we're going to do that now and see where that takes us. So then 0 is equal to a over 2 minus 1. Now, once you substitute those, there is only one variable left, and we can find it by using algebra, and that is a. So how do I get a on its own in this case? Where do we start? What do you guys think? Take away the -1, which means do the inverse and take it over to the other side, right? So -1 will go over to this side, where it becomes a +1 is equal to a divided by 2. Now we still have a 2 that we can get rid of on my right-hand side. And how do we get rid of it? Thank you very much. I'm going to multiply by 2 on both sides. These 2's will cancel out, and therefore a is equal to 2. Now we have all the components we need, because f of x will be equal to 2 over x minus 1. That's it. All right, guys. So whenever you're given a graph, you just go back to the general equation and you substitute what you have been given. All right. Now let's move on to today's lesson, which is exponential graphs. Now, exponential graphs look an awful lot like hyperbolas. The only difference is you either only have this curve over here or only this one over here. So there's only one curve when it comes to exponential graphs. Okay, now what we want to learn today is what happens if a, this is our general formula, f of x is equal to a times b to the power of x plus q. We want to know the effects of a on the shape and direction of this graph. Okay, now the first thing that I'm going to say is if a is greater than 0, then your graph will curve up or upwards. Okay, I'm going to show you now what I mean by that. All right, so your graph curves up. But if a is less than 0, then your graph curves. The English is obviously not my strong point here. Your graph curves downwards. Okay, so this is what I mean by curves upwards. This would be a graph that's curving upwards, okay? And then a graph curving downwards would be something like so. So depending on what your A is, remember we are sketching these graphs, not plotting points and drawing them. So you need to know, depending on which A you get, what the A is, then you need to draw it correctly. Now let's start with those two only. Let's start with the first one. F of x is equal to 3 to the power of x plus 1. Another thing that is the same for hyperbolas and exponential graphs is my Q, because that tells me my asymptote. So yes, these graphs also have asymptotes. And if my Q is positive 1, what do you think my asymptote for the specific graph is? My asymptote will be 1. That is correct. All right. So then I'm going to write here a 1, and then I'm going to draw in my asymptote. When you sketch these graphs, you better make sure you draw in your asymptotes. So there's my dotted line, which represent my asymptote. And this is the line y is equal to 1. Great. Now let's look at A, right? Let's look at A. Is my A positive or is it negative? Is my A positive? It's positive. So will my graph curve up or down? It curves up. So it's going to start somewhere on the side and curve all the way up. Now we want to know where on the y-axis it's going to pass. But what do we call that? What do we call that point where your graph passes your axis? Your y-intercept. Beautiful. So that means we need to find my y-intercept. And to find that, we're going to make x equal to 0. Okay, now let me check again. It's 3x to the power of 1. So y is equal to 3 to the power of x plus 1. So then if I make my x 0, what happens here? Anything to the power of 0 is? Thank you. So then I'm end up with 1 plus 1, which means it's going to pass my graph at 2. So if that is 1, this is 2, that is where my intercept will be. Okay, and now you just sketch it. You know it curves up, so you start somewhere from this side, going that way. Nope, that didn't start very well. Let me fix my writing pad. Going that way. There we go. And that's your exponential graph. That's it. Isn't that easy, guys? So you know, firstly, you find your asymptote, and then you find the direction, curves up or down, and then you dice. I love it. I love it. And then you just sketch your graph after you find your intercept. All right, now let's look at the second one. Okay, let me label this f of x so that we don't start getting confused here. This graph is f of x. I'm trying to go a little bit slower than we did on Monday because that was a lot. All right, so let's look at g of x. Firstly, asymptote. Do we have an q value? Let me start with, do we have a q value for g of x? No. So that means my asymptote is where? That means where is my asymptote? Nice. It will be at 0. Okay. At the line, y is equal to 0. So it's over here. I'm using a highlighter so that you can see where it actually is. And while I'm doing this, is a positive or is it negative? For g of x, is a positive or negative? It is negative, right? So does that mean my graph will curve up or curve down? That is a down curve. Okay, now let's check where it's going to pass by my y-axis. So I have y is equal to negative 2 times 2 to the power of 0, okay? This is just negative 2 times what? Because 2 to the power of 0 is equal to 1, so it crosses at negative 2. So I have negative 1 over here, negative 2 over there, and that is indeed my y-intercept. Wonderful, guys. Now you draw in your graph. You know your asymptote is all the way over there, so your graph must be getting closer and closer to that asymptote. Then it goes that way. I think my curves look a little bit better today. This is g of x. Okay. Now, we have a h of x here with a positive a, but now I have a fraction over here. Okay, so that moves us to the next two. If a is between 0 and 1, then graph will still curve up. That doesn't change. But it will be reflected on y. Now, this is what I mean, okay? It will still be an up curve. Don't look at how I'm drawing it. Just look at what it looks like after. So it will look like that way. Do you see? So it just flipped over. That's what it looks like. So then what do you think will happen if a is between -1 and 0? Firstly, will it curve up or down? Seeing that a negative between -1 and 0 is a negative fraction. Do you guys understand that? This is a negative fraction. So we know it's going to curve down because it's negative. But it will be flipped. Nice. So it curves down, but it also is reflected on y. So then instead of going that way, it will go that way. All right. So we're with me. So let's look at this one. Do we have a Q value? Do we have a Q value? No, which means my asymptote is also the line y is equal to 0, which is this one. I'm drawing it in pink so that you can distinguish that I have two asymptotes here. All right, now let's look for my y-intercept for this one. Okay, y is equal to 1/3 to the power of 0, which means y is equal to what? 1/3 to the power of 0, which means y is equal to just 1. Did I do that correctly? Yes. Yes. Okay. Now, if I know that my graph is going to look like so, I'm going to draw in my intercept, which I'm doing in red. Guys, I'm trying to use a lot of colors here so that you can, yeah, you just need to concentrate, right? But instead of curving that away, it curves. Now I put down curve on my graph. It curves that way while getting closer to the x-axis. And this one is called h of x. Okay, guys, and then the last thing that we always know, Q moves the graph for what? Is it vertically or horizontally? For all the graphs that we've ever drawn ever, if there's a Q value, does it move it up and down or left and right? It's vertically. So Q moves the graph vertically. All right. Do we understand this, guys? Can I have a thumbs up, thumbs down? I tried to go at a nice steady pace today. Okay, I only have 2 thumbs up for 14 people. I'm going to need more responses than that, guys. Way more responses than that. All right. So this is the crux of the matter. If a is greater than 0, my graph is curving up. If a is less than 0, my graph is curving downwards. Okay, if it's between 0 and 1, so if it's a fraction, then it'll still curve up, but it is on the other side. Okay, and if it is between -1 and 0, it still curves down, but on the other side. Great. Now, let's sketch the following graphs. Let me first label my axes. Y, X, flip, flip. Okay, let's look at f of x. Okay, so we haven't spoken about this, but I'm just going to mention it just because the effect of b. So we spoke about A, but the effect of B is the steepness of the graph. What does steepness mean, guys? What does the steepness of the graph mean? Let's just pretend the gradient. Okay, let's just pretend we are talking about the graph 5 to the power of x. This is an exponential graph like the ones we've been doing, right? Your first point, let's say 5 to the power of 1 will be at 5. As soon as you go to 5 to the power of 2, you're already at 25. Do you see how quickly this is increasing? And then you go to 5 to the power of 3, you're already at 125. That is a fast increasing graph, or it's increasing. It's a very steep graph. So instead of a graph that would look like so, this would look more like so, which means it increases faster, because the more you are working these points out, the quicker it increases. So just in case at school you do talk about B, then just know that the effect of B is the steepness of the graph. How quickly is this graph increasing? All right, guys. So let's get going with f of x. We have 5 to the power of x plus 1. First things first, what is my asymptote for this graph? My asymptote is +1. That is correct, okay? So you go and you draw. I have a question before we go there. Why have I not bothered to look for an x-intercept? So far, not once have we looked for an x-intercept, and why is that? Because the graph doesn't even touch the x-axis. Do you guys see that? So look here. If it doesn't have a q value, then your asymptote is the x-axis, so it won't even touch it anyways. But if it does have a q value, it moves it even further up. Do you see that, guys? If this was negative, then maybe you would have an x-intercept because it would be over here. Yes. But only for an increasing graph. Only for an increasing graph. Because for a decreasing graph, that wouldn't help because it will still go that way, which is avoiding the x-axis. Do you see, princess? Does that make sense? So we need to make logic of these things. The reason I haven't even been looking for the x-axis is I know that it is my asymptote in this case. You're not allowed to touch it. All right. That's just in case anyone was wondering why we didn't even look for the x-intercept. Now let me draw in my decreasing q have to be positive. That is true. In a decreasing graph, it's going that way, that it would have to be positive because it would have to be there somewhere for it to cross my x-axis. You guys are getting this? Okay, nice, guys. I like the thinking. I like the thinking. Okay, let me get going with this. Great. So we have our asymptote. Firstly, is A positive or is A negative? Let's see. A is positive, so what type of curve do I have? Upwards, so it curves that way. Okay, great. Now let's find my y-intercept. So y is equal to 5 to the power of 0 plus 1, which is equal to 1 plus 1, which is 2. Do you see a trend here? Has anybody seen the trend with the y-intercept? What is the trend? So far, we've only had the same y-intercept. Have you guys noticed that? It's always 2 because no matter what is here, no matter what is there, it'll make this whole thing 1. Do you see that? I like it. You guys are observant. Okay, so at 2, that doesn't mean you do not work out your intercept because there are times when it won't be 2. I'll show you just now. Okay, now let's see. Okay, so this is an increasing graph. So I start very close to my axis and then I go upwards. And this is the graph f of x. What if the asymptote is horizontal instead of vertical? Then it's not an exponential graph. It is probably a log graph. But we haven't done that. Okay. Yeah. So in this case, all we worry about is the horizontal asymptote. Because even if you move this graph that way, right? Let's say I take this graph and I move it sideways. I move it there. It might not cross at 2, but because this graph keeps going and going and going, eventually it's still going to cross my y-axis. So it doesn't make sense to have a vertical asymptote because it is going wider and wider and wider. All right. I like your questions. They're very interesting. Moving on to g of x. Let's start off with our asymptote. Our asymptote is negative what? Asymptote. There we go. So I have -1, -2, and -3. My asymptote is all the way down here. I suggest you also write the equation of the asymptote. So I'm going to write here y is equal to -3. I'm going to go back to the first one and write y is equal to 1. Great. Now, is A positive or is A negative? Is A positive or negative? It's negative. So what type of graph do we have here? A decreasing graph. No. A decreasing graph. Okay. But now, is it a decreasing reflected graph or is it just a decreasing graph? Is it decreasing reflect? Nice. So it doesn't go that way, it goes that way. Guys, I'm on fire with my curves today. I'm so proud of myself. Okay, let's look for my intercept. Y is equal to 3. I can imagine. We didn't have EGD when I was in school. So in this case, we make x 0 minus 3. That means it's going to be -1 minus 3. Remember, the negative is outside the bracket. So it's not just 1 minus 3, it's -1 minus 3, which is -4 or -4. So then, just after this at -4 is my y-intercept. Okay. And then we draw our decreasing graph, getting closer and closer to the asymptote that way. And this is g of x. Okay. Now, we already spoke about asymptotes, right? That move when Q moves. But let's talk about the quadrants. Okay, let me number the quadrants quickly. 1, 2, 3, and 4. Okay, now quadrants 1 and 2 are for when A is greater than 0. Okay, so if your A is greater than 0, then you know it's going to be in quadrants 1, not 1 over 2, 1 and 2. And of course, if A is less than 0, your graph is going to be in quadrants 3, and 4. That is provided we don't move it, right? It's possible to take this graph and say -5, and then it ends up somewhere here. But for the ordinary normal graph, if you are sketching the original graph and you haven't moved it, this is the rule. All right. I'm hoping you guys feel a bit better about this. Can I have a thumbs up, thumbs down? Thumbs up. I only have one other thumbs up here, which is shaky, guys. It's shaky. Where's everybody else, guys? I'm starting to feel we're not watching. There we go. No, there isn't a brain break. Sorry. Great. Now we have to find the equation of these graphs. Okay, that means we're going to be given graphs. So we need to determine what the equation is. So we have a graph over here. We've been given our asymptote, and we've been given our y-intercept. So they've told us that this graph's equation is f of x equals a times 2 to the power of x plus q. And we need to find the full equation of this graph. Which one can we fill in first? We're looking for f of x, a, and q. Well, no, actually, we're looking for a and q in order to find the equation of the graph. Nice. We can substitute -8, which is our asymptote, into q. So then we have a f of x is equal to a times 2 to the power of x minus 8. Great. Now, this -4 is not just -4, it is a point. It is the point 0, -4. Okay. So -4, we substitute into f of x. F of x, once again, is the same as y. So -4 is equal to a times 2 to the power of 0 minus 8. And if you're wondering where I got all of those, this is where 0 comes from. And this is where the -4 comes from. Okay, nice. Take the -8 over. So I'll have -4 plus 8 is equal to a times 1. And what is -4 plus 8? -4 plus 8. Therefore, a is equal to 4. 4 is equal to a. Now we have all of our components because we can write my equation, which is f of x is equal to 4 times 2 to the power of x minus 8. Easy enough, guys, isn't it? Easy enough. No? Gift? Is there anything I can explain? Okay. Don't be shy to ask. Okay. Now we have those cases where the graph actually has a x-intercept. Remember we said a decreasing graph with an x-intercept will cross. I mean a decreasing graph that is moved up. See, it's moved up. My asymptote is +3 instead of 0. So a decreasing graph that is moved up will have an x-intercept. And in this case, we have exactly that. Let me highlight my asymptote as well. In this case, we've been told that g of x is negative b to the power of x plus q. All right, now let's get substituting. Yes, decreasing graph with a positive asymptote, yes. And then an increasing graph with a negative asymptote. You guys get the point. All right, let's look here. Where do I substitute first? Where can we substitute first? Gx and -1. But what is the point for gx? What is this point actually? What are the full coordinates of this? Nice. So this point is -1 with 0. And remember, coordinates are an x and a y. And y, we said, is the same as gx or fx. Okay. So I can say 0 is equal to, it's okay, I understood what you meant. Negative b to the power of -1. And what do we substitute by +2? Plus q. We substitute a 3 because that is my asymptote. All right, now let's go ahead and solve for b. Who do we get rid of first here on my right-hand side? Nice, 3, okay. And if 3 gets over, or what is the inverse operation for +3? It's going to become -3 is equal to negative b to the power of -1. Great. Now what? Now what? Now, if there is just a negative here, there might not be a number, but what is the number there? A -1. Okay, so we don't want a -1. We want a positive b. So I'm going to divide both sides by -1. You can actually times both sides by -1 as well, princess. That's completely makes sense. So then you're going to be left with 3 is equal to b to the power of -1. Now I want us to go back to the laws of exponents. What happens when you have a negative exponent? What does that mean? It's a fraction. We'll put it in the denominator. So then 3 is equal to 1 over b. Are we solving for 1 over b here? No. Okay. So what do we do to get b back to our numerator? We don't times by 1, but we do times by something. You can do that. Yes, you can do that. That is a good suggestion. I'm just going to times both sides by b. So this one will be gone. And then I'll have 3b is equal to 1. And then I have to get rid of this 3 in front by doing what? This is the same as cross multiplying, by the way. Divide by 3, divide by 3, and that 4. These ones will cancel. My b is equal to 1 over 3. So then, what is my equation? My equation will be g of x is equal to -1/3 to the power of x plus 3. Nice. Nice, guys. So we've gotten into the habit of just looking at what we have and substituting it right in. Okay. Nice. Okay, we have another one. In this case, they made it easy for us because they didn't just give us an intercept, they gave us a whole point. They gave us coordinates. Right. We actually have 3 points here, but I'm not going to talk about it now. Great. Oh, I see why we have 3 points. What's my third point here? I have a 2, 1. I have a -1/3 with 0. Nice narration. It's passing through the origin, which means this point is 0, 0. Okay, now we're going to get to the mathematics. Okay, why do we need 3 points in this case? Why do we need 3? You cannot get the gradient of this because it's a curve. It changes. Okay, so the gradient there and the gradient there are different. Okay. But let's see. let's start substituting, and then you guys will see why we needed 3 points instead of 2. So my equation is y is equal to a times b to the power of x plus q. Let's substitute the q. Okay, what is q in this case for this graph? There we go. Y is equal to a times b to the power of x minus a third. Great, that's out the way. Now I want us to first use this point that's up here. Okay, now if we use that point that's up there, that means my y is going to be 1 is equal to a times b squared minus a third. Can we solve for any of the variables right now? Can we solve for any of these variables? No. There are 2 unknowns. Do you see that? I'm going to move this guy this side to make this easier. And what happens is I'm going to have a times b squared is equal to 1 plus a third. Look at my maths now. 3 over 3 plus 1 over 3 is 4 over 3. Okay. Now, tell me where I'm going. Lerato, I'm going to stop right here because it's going to get more complicated. Okay. So I need you to tell me where I have lost you. I see you just joined. So we're finding the equation of the graph. Okay. So this is our graph that we've been given. And we've been given the general equation, which is over here. All right, so we just substitute what we have. Firstly, we have an asymptote, which is over here. And we always say that Q is your asymptote. So that's where this 1 over 3 came from. Negative a third came from the asymptote. Then I took a point 2, 1. Remember, points or coordinates represent an x value and a y value. That means wherever I see x, I can substitute 2. And wherever I see y, I can substitute 1. And that's all I did. Do you see that? Here. Then I just move my third to one side so that I can have both my variables on one side. Are you with me? Now I'm going to give you guys a clue on how we're going to solve this. I'm going to write dot, 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 1. What does that mean, guys? What does that dot, 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 1 mean? Oh, we're going to have to do simultaneous equations because we have 2 unknowns. Do you see why we needed 3 points? Because for my equation 2, I can't use the same points. That doesn't make sense. So I'm going to say a times b to the power of x minus a third. This time, which points are we going to use for equation 2? 0, 0. So 0 is equal to a times a b to the power of 0 minus a third. And then we're moving our third over that side. So it's going to be a third is equal to a times what's b to the power of 0? B, so it's 1. Thank you. Therefore, my a is just a third. And this is my equation 2. Now, what am I going to do with equation 2? Substitute 2 into 1. Okay. I hope it makes sense now why we needed 2 unknowns. So I'm going to say, right, sub 2 into 1. So then a third, which is my a, times b squared is equal to 4 over 3. Okay, now let's get going. How am I going to get rid of this third? To get my b squared on its own. How am I going to get rid of the third? Divide by 1 over 3. But dividing by 1 over 3, okay, we'll go into that just now. I don't want to do 100 steps in one. This will go away. Then I'll be left with b squared is equal to, now how am I going to solve this guy over here? We can tip in times. So it's going to be 4 over 3 times 3 over 1. B squared is equal to 12 over 3, which is 4. So now I have b squared equals 4. We still need to find b. All right, so then I square root. Why am I not doing the plus minus in this case? Why am I not doing the plus minus? Have you ever seen so far a b that is negative? Do you know why? Do you think a b that is negative will ever make a graph? Because let's look here. I'm going to say negative 2 to the power of 1 is negative 2. Negative 2 to the power of 2, what is that? What's negative 2 to the power of 2? There we go, 4. But then if I say negative 2 to the power of 3, we're back in the negatives. But then negative 2 to the power of 4 is positive. Do you see we have a problem? How are you going to draw this graph? One point is in the negative, and then the other one is a positive, and then the other one is a negative. See, so this is not, we don't have exponential graphs like this. Are you with me, guys? This is not an exponential graph. Make sense? That's why we always say, if you're solving for b, it will be positive. Because otherwise your point will be 1 over there, 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 1 over there. Okay. Wow, Narisha. So b is 2. Now let's write. I even forgot we're looking for our equation here. We've been doing this for a while. Okay, so then my equation, y will be equal to, what was a? A third times 2 squared minus a third. Ooh, that was lovely. Can I have a thumbs up, thumbs down? Lerato, I know you just joined, but are you good? Did this make sense to all of us? Nope, there is no brain break. Wonderful, Lerato, as long as you're with me. You guys are leaving early anyway. You're going to do the quiz. Not yet, though. Can I have more thumbs up, please? Thank you, Zeketelo. Thank you, Princess. Narisha, are you not sure? Up, down? What is the problem? Is it the simultaneous thing that gave you, that made it a bit shaky? Guys who are saying 50-50, remember, if you see that, the reason we needed simultaneous is you ended up with 2 unknowns. If you look here, over here, they gave us a. Do you see that? It's -1. And this one, they gave us a again. Do you see that? Does this make sense, guys? They gave us b, excuse me. On this one, they gave us b. B is 2. So in these 2, we had at least one of them. But with this one, we didn't know both a and b. So you substitute twice. Then once you find the one variable, you have to go back and substitute it to find the other variable. Okay, guys. Excuse me. Okay. And now we're back to not so bad. Not so bad. Okay, let's do this one. This time, once again, they have already given us b. Do you see? Why does this look familiar? Okay, never mind. For a moment, it looked familiar. Just checking the last time. Okay. Okay. Okay, -4 is our asymptote, which means it is the point, 0, -4. And then, of course, we have, it's not a point, guys, it's a line. Why am I, it's a line, -4. The intercept is 0, -3. Oh, all right, so let's get going. I'm going to substitute all of them at once, okay? So this is my x, the 0, and my y is -3, which means I'm going to say -3 is equal to a times 2 to the power of 0 minus 4. Okay, I move my -4 over, so I have -3 plus 1 equals a. What's -3 plus 4? I already told you the answer. What's -3 plus 4? My brain was a few steps ahead. -3 plus 4. A is +1. So then your graph, f of x, has the equation 2 of x. I'm not writing 1 because 1 times anything is just that thing, minus 4. Okay, we have a last one. One final one. Okay, once again, we have a random point. Do we have a in this case? Are you sure? It's 1. Lovely. They tried to trick us, right? There's nothing. If we didn't have a, they would have written a times b to the power of x. Makes sense? But in this case, there's nothing there, so it is a 1. Okay, so then I'm substituting. Now, just for me, I'm going to write x and y so I don't forget. I also got tricked. That's why I asked you, because I quoted quickly. 2 is equal to b to the power of, not x, b to the power of -1 minus 1. Okay, -1 goes over, so I have 3 is equal to 1 over b. Okay, and then these go around, so then b will be equal to a third eventually. And that is expected because my graph is not increasing that way, but is increasing that way. Okay, so sometimes look at the cues from your graph. So then our graph will be g of x is equal to a third to the power of x minus 1. And we are done, guys.